Hello. Can you hear me? Does everything seem okay? You should see the desktop. You should hear me. Does everything seem okay?
Yep, everything's okay.
Great, thanks. Okay, we get set up. Okay, today we're going to start looking at language 6, which adds more features to our language. We're going to finally have loops and if statements in the language. Okay, so let me download language 5, language 6. Uh-oh. Huh. It's there. I forgot, I gave it the wrong URL. Okay, there it is. I have to fix that. It's just in the wrong, it's got the wrong URL here. Okay. Close that. So let's look at how we add okay. Clean up a little bit. Okay, so language 5 was this language with local variables and lexical scope. Okay, so remember it was local variables, lexical scope. Var declares a variable, set updates a variable, and begins a new scope for variables. Okay, so now everything else was the same as all the languages beforehand. Now we're going to, for language 6, all we do is add we're going to add two new terms to the language, if and while. Okay, now everything else stays the same, and the interpreter for language 6 is nothing but a little bit added to the interpreter for language 5. There's, you know, we're growing the language by just a little bit to add the if and the while. Okay, so for all of this stays exactly the same as it was over here. Okay, so the only thing we have to do is describe what does if mean in this language and what does while mean. Now the syntax for if is you type the word if and then you give 3 expressions, a Boolean expression, and then an arbitrary expression for the then part when the Boolean is true, and an arbitrary expression for the else part when the Boolean is false. So an if statement has a tree with 3 branches, and a while loop is a tree with 2 branches, a Boolean expression, and an arbitrary expression. Now, there's one thing that's a little bit interesting about these things is what about this is a language of expressions. So everything here has a value. Everything returns a value. And the question is, what should now that's different than the Java's if, okay? Yeah, if I bring up Dr. Java and go to the REPL, yeah, there's something that's, I'll show you this as soon as it starts up. The if in Java is called an if statement. The if in our language is called an if expression. And Java has an if expression that's got different syntax from the if statement, okay? You can't do something like this. You can't say int x equal if true for else 5. Okay, that doesn't work in Java. Okay, you can't. This is a valid piece of Java, but it doesn't give you a value. It doesn't give you something you can put into X. It's not an expression. It's what we call a statement. So if you execute this, you get invalid variable declaration. Okay, now if you just do the if true for else 5. Oh, let's see. Oh. See, notice it said expression statement required. The interpreter doesn't like that because the interpreter wants to give back a value, and an if statement is not an expression statement. See, it's a if statement that's not an expression. It doesn't give back a value. There's nothing to print. Okay. Even if you do something like, we'll see, if you do if true system.out.println 5. Now notice I'm not returning anything. If true, print out 5, else print out 4. Okay, notice it printed 5. And it didn't reach, it accepted this thing because it didn't try to return, it wasn't trying to return anything, it was doing something. Okay. If statements, let me change those to print lines. If statements do something, they don't return something. Okay, they do something, they don't return something. Okay, if you want to return something, use what's called the ternary if expression. You'd say true, well, the expression looks like this: expression, question mark, expression, colon, expression. Okay, notice it's got 3 pieces. The Boolean part, if this is true, evaluate this. If this is false, evaluate this. This is called the ternary Boolean if expression in Java. So like I can say true for 5, see, return 4. If I say false, returns 5. I can say int x, well, now I can use this int x equal. X is 4. Okay. This guy, remember, this guy, it has the syntax of expression, question mark, expression, colon, expression. And you can put this anywhere. Like you can do 5 plus true, question mark, 6, colon, 2. Oh, I think I need to put parentheses around it. There, see, I need to group it properly because of the order of operations. So 5 plus, then it evaluated that expression. You can put that expression anywhere you want. It's something that returns a value. That's the ternary if expression. Our language over here is like this if is the equivalent of Java's question mark operator. See, it's got 3 branches, just like this one's got 3 branches. The syntax is just a little different. You say if branch, if expression, expression, expression. Here the syntax is expression, question mark, expression, colon, expression. But the idea here is exactly the same as the idea here. An if expression, which is different than Java's if statement. The actual thing that we put the word if in front of in Java is actually called an if statement. It does things, it doesn't return something. Okay, you can't bury it in the middle of where an expression would go. You can put it inside of another if statement. You can put it inside of a function definition, but if in Java, function definitions are statements. The lines of code in a function in Java are statements, not expressions. Java is not an expression language. Over here, we're designing things the way more modern languages are, like Haskell and ML and Lisp and Rust. Those are all expression languages. Everything in the language actually is an expression. So like in our language over here, let me start up the interpreter. Here's what I mean by it's an expression language. In Java, I can't say something like int x equal int y equal 5. It's not going to, that just doesn't work. I can't declare, but over here, I can do that. I can say var x, what should the value of x be? Well, var y6. Okay. Now, what var y6 does is it creates a variable named y and gives it the value 6, and it returns the value 6. So that 6 is what also gets associated to x. So now I have, see, first I put y in the environment with value 6. That evaluated this expression in here. And it returned 6, because var is an expression. It returns something. So then what it returned can be assigned to x. Okay. Now, in Java, you can do something like this. You can say, okay, if I declare x is 6 and int y is 7, you can do this. Okay. Now x is 0 and y is 0. But that's an assignment. Assignment is an expression in Java. Okay. X plus y equals, let's see if this works. See? Or, okay, x equal 10, y equal 0, x equal x plus y equal 100. Okay, now what's that going to do? Assign 100 to y and return the value 100. So now y is 100, but this expression returns the value 100. Then it adds 100 to what x is. That's x is 10, and then stores 110 in x. Okay, so x, and it returned, notice it returned 110 because the assignment expression returns a value. Okay, so assignment in Java is an expression, but declaration in Java is a statement. So you can't combine declarations. In our language over here, it's a little bit more modern. The declaration is itself an expression. So the value of the declaration is the right-hand side. So var z7 returns 7. See, this was the return value down here. It put 7 in the environment and it returned the value 7. Okay. And in this language, I can do something like var a, I can say set x, okay, set z -10. Okay. The set changes the value of z, but it returns -10. So var a is going to have the value -10 now. Okay. See, a had the value -10, and z got updated. So set has the side effect of updating the environment, but set is an expression, it returns a value. Okay. Assignment in Java is like our set, it's an expression. Assignment updates a value in the environment and it returns the right-hand side. They did that so you could do things like x equals y equals z. They wanted you to be able to do that kind of thing. Except I didn't declare a z yet. Okay. You can do this. You can try to figure out what this means. Yeah. It took the value of y, updated x to be the value of y. then that returned the value of y, and that value of y was assigned to y. Then the value of y was assigned to x, and that value was returned to the value of y again. Okay, and then the value of y was assigned to x again. So it just keeps assigning values over and over again. But you can write silly things like this because, oh, and the grouping is from right to left. The grouping looks like this. This is one of the few operators that is associated from right to left. See? So that's the way it's grouped. It assigns y to x, does that first. The value of this is the value of y. Then that value is assigned to y, and the value of this expression is the value of the right-hand side. So the value of an assignment is the right-hand side. So assignments are expressions. So in our language that we're building.
Can I ask a quick question?
Sure,
Does that have anything to do with the stack?
Well, the stack is the environment in Java.
Right.
Yeah, so yeah, you're right that we're creating an environment object because we're not writing a language that's compiled. But see, this would be the stack in Java. That's where the variables are. Is that what you mean?
Yeah, yes.
So, when
that's why it goes from the right to the left for that.
No,
Oh,
that's got
no?
nothing to do with
Okay.
the stack.
Okay.
No.
Okay.
This has got nothing to do with the stack. No, not at all.
All right.
This is right associative. The equal sign is right associative. So when I type this, it's evaluated first this, then this, then this. It's evaluated from right to left. What this has to do with the stack is when I say int b equals 8, I declared a new variable in the stack.
Right.
That's what's in the stack. The stack now has b in it. Okay. Along with x, y, and I don't remember if I have an a in there. Okay. But the order of operations has got nothing to do with the stack. The order of operations has got to do with the way you group things. So for example, I can do the following, can I? What's this going to do? What's that mess going to do? If you write code like this professionally, you'll get fired, but it's valid Java. What did it do?
Assign 9 to y and add it to the 8 that was assigned to y.
Well, wait a minute. But wait. What 8 there was assigned? Yeah.
Oh, the middle one.
What? There's only one y.
Right. But first you're going to have a 9 that's going to get added to 8 that's going to get added to 100.
Well, no, but you're blurring. What you're doing is blurring it all up now.
Right.
Okay. What does that do?
Well, it's in the parentheses. So it's going to assign 9 to y.
Right. And
then add that value.
No. Before it can add anything,
it
assigns 9 to y and
returns it.
And returns 9. Yes. So the value of this parentheses is 9. And it puts a 9 into y. Okay. Now, so there's a 9 over on this side. Now, what does this do?
Assigns 8 to y and returns it.
Yeah, returns 8. Okay. Now, what does the 8 get added to?
The 9.
The 9 that was over here. But what's over here?
Another y.
Maybe. Well, yeah. It's a
but
y.
It's a different. It's the original
No, there is no such thing as there's only
Well-
one y. You can't talk about the original y.
Okay.
That doesn't make sense. You are the same you were 15 minutes ago. There
Yes,
wasn't
well-
an original you 15 minutes ago and a new you now. This y is the same y. There's only one y. It's on the stack. It's a variable on the stack.
That y holds the value of 100 though.
Well, see, the trouble is we have to actually ask what order is the operations being done in. Okay. I think what it was is the order of operations was to start over here and get that y, which was 100.
Okay, yeah, it must be otherwise.
Yeah, get
It would
that
be an
y,
8.
which is 100, and then that value is 100. Now, replace 100 with 8. So and return 8. So now you've got 100 plus 8 is 108. Now replace 9 with y with 8 with 9, return 9, and add 9 to 108 and get 117, and y is 9. So this was done from left to right. Okay, it was executed from left to right. Okay, you can make this stuff even worse by doing things like this. Oh, that one, okay, that one I won't even accept. Like that. It's very hard to figure out what that's doing. You start with that y, then you assign 8 to y. Then the trouble is over here. This is post increment, but increment after what? Would it be after you've done the addition? Let's see. So this should give us y is 9. Yeah. And if we make this, say, a 3, like if we make this a 3, now y is 4, because after we assign y to 3, we did plus plus y. Okay. Yeah. But notice this is a weird mixture of side effects and expression values. This is a bizarre mixture of a side effect is the fact I put 3 in for y in the stack. The return value is 3. The side effect is I change the value of y in the stack, and that's the side effect, and then the return value. So this thing has both a side effect and a return value. This has both a side effect and a return value. Up here, this had a side effect and a return value, a side effect and a return value. It did something and it returned something. And this had a side effect. It did something, it updated X. Okay. Languages like we're designing over here in more modern languages, you try to minimize the side effects and maximize the return values. So everything gives you back a return value, and you try to minimize the things that have side effects. So for example, some functional languages don't have a set in them. They get rid of that. They don't allow you to ever change a variable. And they don't have things like the plus plus and the minus minus operators. You don't change variables. Okay, those are what those languages have what are called immutable variables. So then if you get rid of this, if you get rid of that, everything else in here is a value without side effects. The only thing that has a side effect is that guy. And also print. Print has a side effect that it prints something out on the screen. Okay, so that's technically a side effect. Oh, and val kind of has a side effect because it introduces a new variable to the environment, but it doesn't change something that's already there. It adds. So in a sense, that's a little bit less dramatic of a side effect. So this updates a variable. This adds a variable to the environment. So this is a side effect, and this is a side effect. If you can't declare variables, you have an awfully hard time having a language. So this kind of side effect is considered okay. Adding a variable to environment is considered okay. But many languages, modern functional languages, drop the set. They don't let you mutate variables. And then again, print is a side effect because it changes the display. So it has the effect of changing the display. Okay. This has the effect of growing the environment. This has the effect of changing a value already in the environment. This is considered okay. This is considered a little bit suspect. So in some modern languages, they don't have the set. Okay. And then almost all modern languages, if is an expression. It returns a value. Okay. Whereas in Java, it's the old-fashioned way, like C and C++. If is designed for side effects. It's designed to do side effects because it doesn't return a value. So then you have to do things like that one. See, the if doesn't do anything if you don't have side effects inside of it, something that prints. Okay, or okay, you could do if true x equal 5, else x equal 15. Now that makes sense because that's saying change the value of x to this or change the value of x to that. But it's the side effects of the true that matter. Okay, that's instead of writing something like x equal. See, in a modern language, you would do this. Okay, if true returned 5, so that's what gets into x. Else returned 15, so that's what goes into x. That's how we would do it in our language or in modern languages like Rust or Haskell. And that's what you could do in Java with the ternary operator. But in Java, if you wanted to set x to be 5, depending on the value of this, you want to set x to 5 or x to 15, you have to write it that way. You have to put the updating of x in here and the updating of x in here. You can't put once. Notice that this is easier to read down here. The advantage of this is you're updating x to the value of either that or that. Because over here, I could do weird things like this. Well, yeah, I could, in this one, I could change that x to a y. Then I'm updating either x or y, and code is starting to get kind of confusing. Why would you update x in one case and update y in another case? In this one, this is considered more clear. You're saying update x. The value of x is dependent on what's in here, and x is going to be 5 or 15. And I can't, and using this, I can't do something weird like, oh, I want to update x or I want to update y if I change that to a y. That's kind of considered bad programming in a sense. Like, it's confusing that sometimes, depending on this, you might update x or you might update y. I mean, that can make sense, but it can be hard to understand and it can make code trickier to understand. And that's why sometimes code needs a lot of explanation, because it's doing weird things like, depending on the value of this, it might be updating x or it might be updating y. Whereas this is real clear. Depending on the value of this, you're going to set either this value or that value to x. Okay. Now, one thing that's interesting from this point of view, I can say int a equal 0, string b equal cat. And I can say if, say, true, a equal 9, else b equal dog. Notice that I'm working with completely different types here, but it doesn't matter. This variable's got type int, this variable's got type string, and it doesn't really matter. Oh, I think I need this. Yeah, forgot the semicolon. Okay. Notice it didn't return a value. Okay, it did not return a value because if statements don't return a value, it did something. It either changed A or it changed B. Okay, in the case of, because I said if true, it changed A. Okay, So the types in, whatever this thing does, and this is real important. This is what's bad about this. Whatever this thing does doesn't actually have to be related in any way to what this thing does. They can be completely different chunks of code, have completely different types. They can have absolutely nothing to do with each other. On the other hand, if you do something like this, if you say int A2 equal, now I use the ternary operator. I can put an expression here and I can put an expression here, but now they're not unrelated. There's something that ties those two expressions together. What is it? This cannot be totally unrelated from this. Remember in here, there's nothing to tie that guy to that. They don't have to have the same type. They don't have to work on the same variables. They don't have to do anything. They don't have to be related to each other in any way. Now, this and this are linked somehow. Then we see in what way are they linked?
A2.
Pardon? Yeah, what about it?
They are related to A2 in some form or another.
All right.
They both.
So I'm going to put Bob here, and I'm going to put 123.4 there.
Well, now one of them's not an integer.
Actually, both of them aren't integers.
Well, yeah, true. The other one's a float.
Yeah. So,
Or a double.
what do I need to put here?
Oh, so they're more tied to the type than the.
Yeah. What's true about this expression and that expression? What do they have in common?
Integers.
What about integers?
It's got to return.
Yeah.
It's got to have something to do with an integer.
What's the value of this expression must be?
Int.
And the value of this expression must be?
Int.
Int, because they're being assigned to this int. Notice that that's a restraint. That's a restraint on this operator that the if statement doesn't have. The if statement has no restraint on what goes inside this piece and what goes inside this piece, none at all. But in a ternary operator, these two have to have the same type. They must have the same type. You can't have one of them be a string and one of them being int, because then you don't have a type for the return value. So if I go here and say string, then what's true about these guys?
Strings.
They must return string values. Okay, they must return a string value. Does that mean that this has to be a string?
No.
No. I mean, notice returning a string value is not the same that something is a string. It returns a string value. It might be a function call. It might actually be a function call, not that returns a string. It doesn't have to be a string. It has to return a string value. Same with this one. This one must return a string value. Okay, so it could be a call to scanf. It could be a call to the scanner that returns a string value. And over here, this could be calling a method on a string, or calling a method. It could be, for example, this one could be that returns a string, if I remember right, integer.parseInt 45. Okay, there's no string in there, but it returns a string. Okay. Okay. This guy's not a string. It's a method call on a string that returns a string. On the other hand, if I did this, This is not valid. Why? There's a string there. So, well, I need to have, this is supposed to be a string. This thing returns a string. That's a string. So I'm good to go, right?
No,
Why not?
length returns int.
Yeah, what it return. It's what's important is what it returns. Yeah, this doesn't need to be a string. It needs to evaluate to a string. That's very different than saying something is a string. When we talk about these languages, we're talking about these things evaluating to a string. Okay, so yeah. Oh, let's see, what did I do wrong? Oh, I thought it was called parse int. Do you remember what it's called? That converts an int to a string. Oh no, not part.
String.
Parse is the one that goes the other way around. Parse takes
Yeah,
in string.
you'd have a
So
string in there.
It should just be toString. There, it's toString method that converts 45. Yeah, parse int goes from goes from string to int. ToString goes from int to string. Okay, now A2 is the string 45. Okay, all right. So this is not a string. It's something that evaluates to a string. This is not a string. It's something that evaluates to a string. When you use the ternary operator, remember the ternary operator is going to be expression, which must be something that evaluates to a Boolean, question mark, expression, colon, expression. These two have to have the same type. And what type they have depends on what this thing is, the context of how this thing is sitting. So for example, if I write 5 plus all this, now I know that these have to be what? In this expression, what do these guys have to evaluate to?
Ints.
Or now look, I'm adding 5 to the result of this expression. What can 5 be added to?
Oh, int, or could it still be added to floats or doubles?
Yeah, it could be, yeah. So these could be both what?
Oh, they could be both of either ints, floats, or doubles.
Well, yeah, they could be both int, both float, or both double. Okay. You can't have one, well, you actually could have one be int and one be double, because then the int is actually be compiled to a double. If you make this one, if you actually went here and say, okay, now true, and you made this one 5, you made this one 6.4, the compiler does not treat that as 5. The compiler actually compiles that to a double, because you can't have a different type here than in here. So the compiler actually converts that to 5.0 for you. Okay. What else could go in there? You could do that. See, now it's 10. What else can go in here? What do they mean by bad type?
Oh, since they're not both strings, it couldn't convert like it did with the numbers.
Yeah,
But in the instance of both strings, then it concatenated to the 5 instead of
adding to the 5. Yeah, it said 5 can be concatenated on a string. So if both of these are strings, it can concatenate. I actually don't know why it said bad type in addition here. I expected it to say that this Boolean operator was wrong. I expected it to say that the Boolean operator was wrong. Let's try this. Oh boy, I didn't even know Java would do that.
so
I didn't know Java would do that.
So in the one instance it concatenated, but in the other one it tried to add a string to the.
Wait a minute.
That's kind of interesting.
Yeah, it returned a string in one hand and it returned an int in the other hand.
But when they were both strings, it concatenated, but in the instance where it returned a string of 5, it tried to add.
Yeah.
Is that why it says bad type
I
in
don't.
addition?
Yeah, it tried to add. It tried to add. It tried to add, but it can add 5 to a string. But wow, this is actually I didn't know Java. I wonder if this is a slight quirk in. This might be a quirk in Dr. Java. This might actually be Dr. Java acting flaky, because as far as I know, that shouldn't work. Let's try. Okay, let's try putting this in the Java visualizer. I have a. Let's go to the Java visualizer. It didn't even like that. Now, whenever you get something's not a statement, the fastest way to make it a statement is just print it. Okay, so this is a statement now because that's a statement, but it's trying to print whatever this thing supposedly evaluates to. Now, to me, this should not evaluate to anything because these have different types. Wow. No, it wasn't Dr. Java. It's now watch. Let's see if this works. See, it wouldn't, now it won't, now it's, this guy printed 6, but this guy won't evaluate the 6. So Java's got too many, yeah, I don't, see, that one printed, this one printed 6, but it won't evaluate to 6. I actually don't know how to explain this. I'm not sure what rules Java is using here. I actually don't understand this. To me, especially if you look at the language like Haskell or Rust and those, this simply won't compile. That will not compile because the rule is that these have to have the same type. So you can't have different. Now somehow Java seems to be dancing around that. Like here, since it was printing the results and it didn't care, sometimes it would be willing to print a string and sometimes it would be willing to print an int. Somehow the compiler didn't care here that these guys had different types. But when you try to assign it to an int, then all of a sudden the compiler says, well, I cannot, even though this is false, so the value is 6, the compiler is saying, no, I can't compile that, which it should have said earlier. See, compatible type, bad type and conditional expression. Yeah. So I'm not sure why the compiler was willing to accept it here. Maybe the Java designers just thought that since the return type doesn't matter here, they're more relaxed in the ternary expression. But I thought the ternary expression was always strictly required. And actually, I'll bet I can find you books that tell you this. I bet anything I could find a book that says that the ternary operator requires that this one and this one have the same type. I'll bet I can find that in print. But here it's showing that it doesn't have to be. Yeah. But notice that I'm not using the type of the value isn't being assigned to anything. So like here, it's being assigned to something, so it makes it more important. Here, it's just being printed. So if I put false there, it prints 6. If I put true there, it prints quote 5. Well, now this is interesting typing stuff. I mean, this is how modern languages are all about typing. They're all about their type rules. See, that one printed the string 5. See, well, I don't even really know that it printed the string 5. I mean, for all I know, it no, I could actually here. Make it, yeah. Yeah, see, it printed the string cat. Okay. So it true, so it printed the string cat. And then if I go here and put false, it'll print the string. It'll convert 6 to a string. Oh, you know what? Maybe that's what it's doing all along. Maybe the compiler, but maybe the compiler's converting that to a string behind our back. Maybe the compiler. So what if I turn this thing into no, see, still didn't like it. See, it's not turning this into a string behind our back, because if it was, then this thing would be okay. String.
Does it matter? Does it matter if you reverse their order, put the 6 where the string is?
Yeah, that's a good question. Yeah, that's a good question. Put the 5 there and put the quotes over here. I kind of doubt it, but that's a good question.
But try and return it to an int.
Okay, now try it. It shouldn't. My guess is, cannot convert. Yeah, but yeah. Okay. So the ternary operator in here acted differently than the ternary operator here. Now the ternary operator here, its type mattered because it had to be assigned to something. The ternary operator here, the type didn't matter, so the compiler seems to actually say, I don't care. It seemed to actually say, the compiler said, since the type doesn't matter, I don't care, and I'll let you mix the types. Which I bet a large sum of money that I can find textbooks that say you can't do this, that you cannot mix the types in the ternary operator. Though obviously you can. Here we're seeing that you can't if you don't care about the return type. I wonder if this is a feature or a bug. There's the old expression, that's not a bug, that's a feature. Yeah, I wonder if this is considered a feature in that, like when you're printing something, so the type isn't so important, you can use the ternary operator with different types. I don't know. I think that's kind of fascinating. I know for sure in languages like Haskell and ML and in Rust, there's no way that this one's going to be accepted. The rule, the hard and fast rule is that the two parts of the if statement have to have the same type, here and here. Okay. Boy, that's weird. So the Java visualizer, so what we were seeing over here was actually, the Java visualizer was doing the same thing as this guy can return an int or he can return a string, which is bizarre. Okay, that's just really weird. That's a quirk of the Java language I never knew was in there. Okay. All right, so that's, but again, see, the type isn't really so important here. It's not being assigned to anything. Let's try one more thing. I bet it's not going to like this. Dog. I'm concatenating on the dog. Now, does it matter if this guy returns string or int? If I want to concatenate on dog, can I concatenate a string on a string?
Yes.
And can I concatenate a int on a string?
In certain cases.
Oh yeah, in any case, yeah. Dog plus 6 is dog 6. Okay. Now this is a little bit like the printf. It doesn't really matter what this guy returns. It's going to be okay to concatenate on the dog, but I'll bet it's not going to like this. But it did. Wow.
If you were in a line that was previously using, like if there was stuff before where it says dog and it was like 5 plus 7 and it was actually adding numbers and then it got to
Yeah,
that
see,
part.
yeah, why did it complain here and says okay here?
I remember back in the first Java class that if you were summing numbers first and then you tried doing a concatenation, there was some weird thing that would happen.
Well, order of
where,
operations matters.
yeah, so then it wouldn't concatenate,
Yeah,
but then
yeah, right.
if you
Yeah,
were
you have to worry.
concatenating first, then it would concatenate actual integers instead of adding them.
Yeah. You get weird little things like let me start another Dr. Java. Oh no, I can't start another Dr. Java. Oh, just over here, like over here. It's things like which ones of those additions are string additions and which one are integer additions.
So it would be 9, 6, 7 would be returned.
Yeah,
maybe?
because the order of operations is to start over here, right?
Mm-hmm.
But that gives you 4 plus 5 is 9. Then you do
Concatenation.
but then this becomes
Concatenation.
negation. Yes, yeah. So that's probably what you're remembering is weird things like that.
Yes.
Like this is addition and this is concatenation. Unless you do that, then addition, concatenation, concatenation, addition, because of the grouping. Yeah. So those were the weird things. Yeah, those are taught in the first Java class. I don't think that's what we're seeing over here, though, because there's, I don't think that's what we're seeing. I'm not sure. Yeah, I'm not really positive because here I've got a ternary expression that can return a string or an int. Okay, and unless the compiler behind my back is doing weird casting, and here's saying, well, that's really a string and that's really a string. So in both cases, it concatenated it treated this as string, and it just behind my back turned that into a string. But then it's fun, what about over here? Why didn't it turn that into a string behind our back and do string concatenation here? But here it gave us type error. Now, if I have time, I'll go look in the rule. This really seems weird to me. I've never seen anybody point out this kind of behavior in Java before. I mean, I always assumed that Java was like Rust and Haskell and ML and these other languages where the rule was actually Let's see what people say about it real quick. They don't even mention types. You have to find something that's sophisticated that'll actually point out that there's types going on. He makes a funny statement here that's a little bit misleading. The value returned can be the result of any Java expression that returns a value that can be assigned to the variable at the beginning of the statement. What if you don't have a variable at the beginning of the statement? See, that's not a rule, because down here we have ternary operators without assigning them to anything. And we're trying to figure out what these things mean. We're trying to figure out, what does that mean? What does that mean? What does that mean? So what he's saying is probably true, but it's not very useful because it doesn't explain all cases. It doesn't say, yeah, because he's only saying that when you have something to the left of the ternary operator, see, something to the left of it, something like that, then, yeah, then you have to match that type, is what he's saying. You know, we saw that. But what happens if you don't have anything to the left of the ternary operator? I wonder if, so notice that unfortunately Java programming languages can be really tricky. I mean, the part of this is the subtlety of what a programming language means. And the reason why this is important is that if you don't know exactly what this means, and sometimes it does one thing and sometimes it does another thing, you can put this in your code somewhere and you think it means one thing, but it actually means something different. And you can have a very subtle bug in your code. These things should not be even the least bit ambiguous. What we're seeing here is definitely bad, because there should be absolutely no question about what something like that means. The fact that there's some kind of weirdness here means that somebody could think they know what this thing means, and it's not what it really means, because it didn't mean the same thing here that it meant over here. Languages should be very precise. And one of the problems with the language like C is it's not precise. C is notorious for having things that are left up to the writer of the compiler, even. There's literally things in the C language where it's up to the compiler writer to decide what they mean. Okay. Let's see if this guy has any, because this guy he's a pretty well-known writer. Let's see if he, see, he doesn't say much either. He's not giving a precise rule here. He's not giving a precise rule. Let me try, see if I can find the Java tutorial. Okay, here's the Java tutorial. They tend to be a little bit more precise. No, is this the right page? That's comparison operator, Boolean operator. Though this is the wrong page. This doesn't have the ternary operator in it. Oh, I'm back to where I was. I'll have to look that up. That's very strange. Okay. All right. But see, types matter. Typing matters. And one of the things that we want to learn is to get used to thinking in terms of types. Get used to thinking about how programming languages should analyze the types of things. So unlike languages like JavaScript and Python where types don't matter, we want languages where types do matter. Now, over here in our language actually don't have the sense of it. The if statement here, since our language does not have types, this can be an integer while this is a Boolean. Okay, so in our, if we go back over here to our interpreter, our language isn't Java. So I can do something like there, W, and I can set it equal to if, say, true, I'll set it to a Boolean. Also set it to an integer. Okay, so W ended up being a Boolean. But if I go back over here and set that to false and make this W2, then W2 is an int. So this expression can return it a Boolean or an int, because this is not a typed language. The language we're developing is not the variables don't have types assigned to them. That's why we use there instead of declarations, like type declarations. So our if statement is an expression. It returns a value, like Haskell, like ML, like the ternary operator in Java. But unlike a strictly typed language, this guy, and this guy don't have to have the same type. In Java, I thought they had to have the same type, and we're seeing that we can do weird things, which I didn't even know you could. But if you look at a more strict language, if you look at Rust, look at Haskell, look at ML, I don't know about C++. I wonder if the ternary operator in C++ might be a little bit more strict than the one in Java. But if you look at the strict languages, it's absolutely the case that this thing and this thing have to have the same type. Those two must have the same type. Okay, you can't do funny things like I'm doing over here, which I didn't even know you could do. You can't do, and those stricter languages, you can't do that. In our language, you can. Okay, in our language, you can. And you can do funny things like this in JavaScript. And you can do funny things like this in Python for sure, because JavaScript and Python are not typed languages. But Java is supposedly a strictly typed language, a strongly typed language. So I'm really trying to figure. I'm really surprised at what weirdness you can do with the ternary operator. Okay, all right. Now, what's interesting about this is the while statement. Well, what I just said while statement, but it's actually an expression. What should while return? If you think of a loop, okay, remember, here's how a while loop works. You start here and you go, okay, evaluate the expression. If it's true, you evaluate this thing. Then you go back here and you evaluate this. If it's true, you evaluate this. Then after you evaluate that, you go back to this one. If this is false, you quit. So what should be the value of a while loop? To me, the value of a while loop is always false, because the last thing you do is you evaluate that guy and it tells you to exit. So the value of a while loop in our languages is always going to be false, because what it does is evaluates this. If it's true, then it evaluates this. But then it goes back and evaluates this thing again. If it's true, it goes back and evaluates this. And if this is true, it doesn't matter what this is, then you go back and evaluate this again. If it's false, you quit. So the last thing you got was false. So the value of this thing is always going to be false. That means you're evaluating these things for their side effect only. You never get their values, you only get their side effects. So your while loop could do things like print things. You could have a while loop that printed things. But if you do a bunch of calculations in a while loop, they're not going to have any effect unless you update variables using sets. Okay, so a while loop doesn't do anything unless it has side effects in these expressions. And it always returns false. Okay. Modern functional programming languages don't have while loops. Because the while loop is kind of quirky like this, it doesn't really have a value. Haskell and ML don't even have while loops. You might wonder how they can do things over and over again if they don't have while loops, and that's where they use recursion. They use recursions for loops. Modern functional programming languages tend to make use of recursion in order to loop because they don't have loops, because loops don't seem right. Loops don't return a value. If I'm going to do something 27 times, what's the value I should return after doing something 27 times? So loops are kind of quirky from the point of view of modern functional programming languages. Okay, so now Rust has loops. I don't remember how it handles them, but I think it does what we're doing. I think I think a loop in Rust, I think, returns false. But Haskell and ML, which are functional languages, don't have loops. They do not have a while loop or a for loop. Okay, I have to go back and look. I think Rust may do what we're doing, which was, I think, just the value of a while loop is false, I think. Okay. Now, as a homework exercise, I'm going to do the following. You're going to do the following. You're going to add a repeat to the language. And repeat is going to look like this. Now, repeat's kind of like, it's the opposite of while. A repeat loop, you evaluate this expression, then you evaluate this Boolean. If the Boolean is true, you go back and evaluate this expression again. Then you evaluate this expression. If this is true, you go back and evaluate this expression. Then you evaluate this. If this is false, you quit. Okay? Now, notice that if this is false, you quit, makes it seem like it should return false. But there's always this thing you did just before you do this. So the value of a repeat is the value of the last time it did this expression. You can actually make the value of a repeat the value of the last time you did this expression. So if you come in here and you evaluate this guy, and this guy's false, then this is the value, return value. Why can't I do that with the while loop? Why can't I say the value of a while loop is the last time you evaluate expression? Think of it, there's a quirk. I can't do that with the while loop.
You might not ever drop into the while loop.
Yeah, because you could enter the while loop and this guy is false and you never evaluate this thing. So you can't say that the value of a while loop is the last expression because there may not be any expression. But the repeat loop enters and always does this guy at least one time. Since it always does this thing at least one time, and then you do it until you get false here, you can say that the value of repeat is the value of this last expression. And some languages do it that way. So repeat is like a real expression where while is kind of funny. It's not really an expression. You know, we'll see. Now, in terms of Java, this guy is a while loop. And this one, in terms of Java, what's the syntax for this thing in Java? Does anybody remember what is it? Do? Is it this? Does anybody remember? I almost never use this thing.
Yes, you're doing it right.
It's a do. So some people call it a do loop. You do what's in here. You do it once, then you check this expression here.
I think you have to put a semicolon after the while, but
the word while?
No, after the last parenthesis.
Well, but see, yeah, but that's true of every expression. Oh,
okay.
Well, no, actually, oh, no, well, yeah, because there's no break. There's nothing like this here. Yeah, so right. Yeah, you need a semicolon there. Mm-hmm. Yeah. So you always do this body one time. So another way you could say this is expression while Boolean expression. So this expression goes here and this expression goes here. You always do this thing at least once. Okay. See, so in Java, that's, I think it's do while. Or is it? Some people call it do while statements. Yeah, Some languages call them repeat statements. Some languages call them do while. Okay, yeah, that's it. Do while semicolon. Yeah, I have trouble remembering because there's between do while and repeat, several. Let's see, who has a repeat loop? I forget what languages have repeat loops. There's a few languages. R. There's several languages that call them. So generically, this guy's often called a repeat loop or a do while loop or a repeat loop. Okay, but notice that from the point of view of expressions, it makes sense to make this a real expression that can return arbitrary values. Whereas this one, it's kind of hard to make sense out of it as an expression. You're kind of stuck. About the only thing you can make sense out of it is it always returns false, because you may never even evaluate that guy. But you always evaluate that guy, but you only quit when it's false. So you make the whole thing always return false. Okay, so this will be in your next homework assignment. I'm going to have you add a repeat loop to the language that's a true expression, as opposed to while, which is kind of a phony expression. It always returns false. Okay, and actually, you have a homework assignment due today, right? And then there'll be another one up there in a couple days, which you're going to add a couple features to language 6. You're going to add this repeat loop and a for loop. Like right now, the language has a while loop, and you'll add a repeat loop and a for loop, which is going to be essentially, it'll be an expression that's initialization part, an expression that's the update part, no, the test part, an expression that's the update part, an expression that's the body of the loop. So it'll be a thing with 4 branches. This will be initialization. This will be the test.
Would that be a Boolean expression? Would
Yeah,
that be a Boolean?
Yeah, this one should be Boolean expression. Yeah, so this will be executed one time. That's the initialization. This will be the test. This will be, remember, the order will be evaluate this, evaluate this, evaluate this, then 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 evaluate this until this one's false. Okay, so you're going to add for loop to the language. Okay, so you'll add repeat loop and for loop, and I forgot one other thing to the language, and that'll be a language 6A. So you'll take 6, and then language 6A, since for loops like the I++, you're going to take your code from language. Your language 6A will be built on your language 5A from the last homework assignment. So you're going to take your language 5A from the last assignment and build on it and make a language 6A, which will have for loops, but it'll still have the, you'll be able to do something like X++, okay? Because you'll have the increment operator, which is real convenient for having in for loops. Okay, so you'll add repeat loop and for loop to the language. Okay, we'll quit there. But what we'll do real quick on Wednesday is look at the actual code in the interpreter, which is very simple. The code in the interpreter for the if statement and the while loop is trivial. That's why I didn't really, it's if this is true, do this. If this is false, do that. That's all there is to the if statement. It's 5 lines of code. The while loop is only a little bit trickier. You just check this, and if this is false, you quit. If it's true, you do that, and then you go back and check this. Okay, it's the code for if and while are very, very simple. Okay, what's more subtle is what we've been talking about, the issue of types, especially the if statement. The issue of types in the if statement, or the if, I keep saying if statement out of habit. This is an if expression. It's real high. It's, in Java, it's an if statement, and you get so used to saying the word if statement, but it's important to realize that this is an if expression. And what's interesting in Java is the distinction between the if expression and the if statement, because Java has both. The ternary if expression. And a language like Haskell only has the if expression. In our language only has the if expression. We only have the if expression. Java and C and C++ have if statement and if expression. And as we found out today, the if expression is much stranger than I expected it to be. Hadn't realized how flaky it was. Okay, so we'll quit there. We'll look real quickly at the code for these two guys on Wednesday. Then we'll start language 7, which is where things really get interesting. Functions. We're going to give our language real functions. It's going to become essentially a baby version of C. We're going to have a language with functions that we can define and call, and they can be recursive, and we can do all kinds of interesting things with these functions. So we'll start looking at a language of functions. Okay, and so the homework assignments due. I looked at it's due this evening, right? Yeah, so there'll be the next homework assignment will be up there probably by Wednesday. If you have questions about the homework assignment, send me email. I have office hours tomorrow. And if you don't have it done by, if you want to come and ask a question in office hours tomorrow, that's fine with me. So it's due tonight, but if you have questions and you want to ask questions in office hours tomorrow, that's fine. You can still submit the homework tomorrow. That's okay. All right. So so if you have any questions at all about this assignment, please ask. All right. So go ahead and quit there, and see you on Wednesday. All right. Bye-bye.